This time, we are going to show how do we multiply permutations. We have 3 permutations here on S6, or an element set containing 6 elements. We have here sigma, tau, and mu. And of course, we can only multiply permutations if they are of the same number of elements. In this case, again, we have 6 elements for each permutation. So how do we multiply permutation? This is what we need to do in multiplying here. Of course, say for example, if we have the product of tau and sigma. In other form, let's write the tau here. 1, 2, 3, 4, 5, and 6. And we have 2, 4, 1, 3, 6, and 5. That's for your tau. For your sigma, you have 1, 2, 3, 4, 5, 6. And you will have here 3, 1, 4, 5, 6, and 2. If we are going to multiply permutations, we're going to do it from right to left. Okay? And our result is also a permutation on the same set. You have S6. Okay? So if we're going to do it like that, I don't know if I have much space here, but this would be equal to, of course, we still have 1, 2, 3, 4, 5, and 6. Okay, that's still the same permutation on S6. So we're going to do it from right to left. In this case, here we will start with from 1 to 3, and then with that, on the tau area, you will have here 3 to 1. That's how you multiply permutations. So 1 is mapped to 3, and you go to the next permutation here, 3 mapped to 1. In short, 1 is mapped to 1 because that's the end mapping. Okay, if we're going to do it on the second, 2 is mapped to 1. Here, 1 is mapped to 2. So this is where you're mapping as well. 2 is mapped to 2. Next, 3 is mapped to 4. So 4 is mapped to 3. Therefore, 3 is mapped to 3. Next, 4 is mapped to 5. 5 is mapped to 6. So in short, 4 is mapped to 6. Then 5 is mapped to 6. 6 is mapped to 5. So in short, 5 is mapped to 5. And finally, for the last, 6 is mapped to 2. So 2 is mapped to 4. So you have here 4 here. As you can see, this is still a permutation on S6. So the product of permutation is also a permutation in the same set. We cannot be sure that our product of permutation is always abelian. Okay, so it's also important to also solve for the for this result for sigma and tau. So let's also try to do the longer method of having 1, 2, 3, 4, 5, 6. So your sigma is 3, 1, 4, 5, 6, and 2. Your tau is 1, 2, 3, 4, 5, 6. So you have 2, 4, 1, 3, 6, and 5. So the result for this, again from right to left, is still a permutation. 1, 2, 3, 4, 5, and 6. So from right to left, 1 is mapped to 2, 2 is mapped to 1. Okay, it's like that. Next, 2 is mapped to 4, 4 is mapped to 5. And just for this second entry or second mapping, as you can see, they are not different from the first. So we don't necessarily say that automatically in a certain product of permutations, commutativity will hold. Okay, so let me just remove this one. Now let's continue. 3 is mapped to 1, 1 is mapped to 3. 4 is mapped to 3, 3 is mapped to 4. 5 is mapped to 6, 6 is mapped to 2. So 5 is mapped to 2. Then 6 is mapped to 5, 5 is mapped to 6, so that 6 is mapped to 6. Okay? So let me go here for the second to the last. This is sigma mu. This is a product of your mu. 1, 2, 3, 4, 5, 6. Okay? So pardon with this, we'll be placing this later at the bottom. Let me just continue with this here. So your sigma is a 3, 1, 4, 5, 6, and 2. Your mu, 1, 2, 3, 4, 5, and 6. That's 5, 2. Sorry, let me do it again. 5, yes, 2, 4, 3, 1, and 6. So if we're going to do it again from right to left, and let me change the color here to black. Okay, so we'll have here the result: 1, 2, 3, 4, 5, and 6. So 1 map to 5, 5 map to 6, 2 map to 2, 2 map to 1, 3 map to 4, 4 map to 5, 4 map to 3, 3 map to 4, 5 map to 1, 1 map to 3, 6 map to 6, 6 map to 2, so 6 map to 2. Okay. For the last item, we have here the square of mu. Of course, we know what does that mean. It's actually just mu times mu, right? So this is just the product of two mu's, and this is actually our mu earlier. So 1, 2, 3, 4, 5, 6, and you will have your mapping to 5, 2, 4, 3, 1, 6. This will be multiplied to itself. 4 map to 3, 5 map to 1, 6 map to 6. Okay. So if we're going to have that, okay, so the mapping is again from right to left. 1 map to 5, 5 map to 1. So 1, 2, 3, 4, 5, and 6. So 1 map to 1. 2 map to 2, 2 map to 2. 3 map to 4, 4 map to 3. 4 map to 3, 3 map to 4. 5 map to 1, 1 map to 5. 6 map to 6, 6 map to 6. So our result for the square of mu is actually our identity permutation for S6. Identity because the number or the element is mapped to itself. This is how we multiply permutations. Thank you very much for watching.